Hello everyone. So I am Maria Nina Agustin and I will discuss about contingency coefficient C. The contingency coefficient is a coefficient of association that tells whether two variables or data sets are independent or dependent of each other. It is also known as Pearson's coefficient and based on the chi-square statistic. The contingency coefficient helps us decide if variable B is contingent on variable A. However, it is a rough measure and doesn't quantify the dependence exactly. So we can use a rough guide. If C is near 0 or equal to 0, you can conclude that your variables are independent of each other. There is no association between them. If C is away from 0, there is some relationship. C can only take on positive values. A contingency coefficient is particularly informative if you're working with a large sample, and you don't need to find out if an association is complete or not, just whether or not the association exists. So we have the formula C is equal to the square root of x squared all over n plus x squared. So x squared is the chi-square statistic and n is the total number of cases or observations in our analysis or study, and C is the contingency coefficient. So let's have an example. So example number 1. Let us examine the relationship between marriage adjustment and education of husband. So we have to calculate the coefficient of contingency, which is the C, for the data given below. So we have the data of graduate, college, high school, and grade schools, in which the marriage adjustment score of husband is categorized by very low, low, high, and very high. So we have the data sets, right? So we have the given data. So we have two total, each row and each column. So the first row we have the total of 105. The second row we have the total of 205. The third row we have the total of 152, and the last row we have the total of 51. So the first column, we have the total of 58. The second column, we have the total of 87. The third column, we have the total of 145. And the fourth column, we have the total of 223. And which the overall total or the grand total is 513. So let us take the step number 1, which is the hypothesis. So our HO or null hypothesis is marriage adjustment and education of husband have low to no association with one another. And our alternative hypothesis is marriage adjustment and education of husband have higher association with one another. So the step number 2 is to calculate the table. So we have to calculate the expected value for each cell. So the row total times the column total, overall the grand total is the formula to get the expected value of each cell. Like for example, in the cell of graduate and the very low, in the row of graduate and the column of very low, which is 4. So to get the expected value, we have to times 58 times 105 divided by 513, because 513 is the grand total, right? So we get the expected value of 11.9, which is in parentheses din right, sa table. So we can see that all of the cell have the parentheses, in which they represented the expected values. So next, we have to calculate the x squared. So x squared, which is the chi-square, right? So the chi-square is the summation of the observed value minus the expected value. So I'm very sorry for the wrong wrong letter. It is supposedly to be kuha na siya din ha, O. Okay? So summation of O minus E squared all over E. Right? So O is the observed value and the E is the expected value. So I'm very sorry for the inconvenience. So let's continue. So we have the 4 minus 11.9. I'm sorry for the for the wrong type. So 11.9 na siya din ha. So 4 minus 11.9 squared all over 11.9 plus 9 minus 17.8 squared all over 17.8 plus 38 minus 29.7 squared all over 29.7 plus 54 minus 45.6 squared all over 45.6 plus 20 minus 23.2 squared all over 23.2 plus 31.34 I'm sorry 31 minus 34.8 squared all over 34.8 plus 55 minus 57.9 squared all over 57.9 plus 99 minus 89.1 squared all over 89.1 plus 23 minus 17.2 squared all over 17.2 plus 37 minus 25.8 squared all over 25.8 plus 41 minus 43 squared all over 43 plus 51 minus 66.1 squared all over 66.1 plus 11 minus 58 squared all over 5.8 plus 10 minus 8.6 squared all over 8.6 plus 11 minus 14.4 squared all over 14.4 plus 19 minus 12.2 squared all over 22.2. So the summation of all the addition and other operations is 32.0.77 907484. So that is the chi-square. So we will get the three places, which is 32.078, right? So next, the step number 4, which is calculate the C. The C is the contingency coefficient. So don't forget about that. So the formula is C is equal to the square root of x squared all over n plus x squared, right? So we have the given chi-square, which is 32.078. So 32.078 all over 513 plus 32.078 times 1/2 or square root. Okay, so C is equal to 0.24. So we will make our decision rule. So step number 5, decision rule. Accept null hypothesis if C is less than or equal to 0. And accept alternative hypothesis if C is greater than 0. And 0.24 is greater than 0. So we will get our conclusion, which is there is low association between marriage adjustment and education of the husband. Okay? So that's all for the contingency coefficient C. Now, let us talk about the Spearman rank correlation coefficient RS. So the Spearman's rank order correlation is the non-parametric version of the person-product moment correlation. So Spearman's correlation coefficient, P, also signified by RS, measures the strength and direction of association between two ranked variables. So we will use Spearman's rank order correlation if we want to know the strength and direction of association between two ranked variables. So although you would normally hope to use a person-product moment correlation on interval or ratio data, the Spearman correlation can be used when the assumption of the person correlation are markedly violated. However, Spearman's correlation determines the strength and direction of the monotonic relationship between your two variables, rather than the strength and direction of the linear relationship between your two variables, which is what Pearson's correlation determines. So what is a monotonic relationship? So a monotonic relationship is a relationship that does one of the following. Number one, as the value of one variable increases, so does the value of the other variable. And number two, as the value of one variable increases, the other variable value decreases. So examples of monotonic and non-monotonic relationships are presented in the diagram below. So as you can see, two of them are monotonic and the last one is the non-monotonic. Right. So, why is a monotonic relationship important to Spearman's correlation? So, Spearman's correlation measures the strength and direction of monotonic association between two variables. Monotonicity is less restrictive than that of a linear relationship. A monotonic relationship is not strictly an assumption of Spearman's correlation. That is, you can run a Spearman's correlation on a non-monotonic relationship to determine if there is a monotonic component to the association. So how to rank data? Let us consider the following example data regarding the marks achieved in a math and English exam. So as you can see, there are marks or scores under the English and maths exams or subjects, right? So the procedure for ranking these scores is as follows. First, create a table with 4 columns and label them as below. So as you can see, the English scores, we have the ranking of them as 9, 3, 10, 4, 6.5, 5, 8, 1, 2, and 6.5. So if you will ask about why there is 6.5, it is because 61 has two is the same. So na siya ka ng pagkapareha. So na duha ang 61, right? So if we have two same scores or variables baron, so we need to get the because we can't rank them or we don't know how to rank them if kanang ang usa ba ka 61 is 7 ba siya or 6, right? So we will take the median which is 6.5. Okay? So and the ranking of math scores is 4, 2, 10, 7, 5, 9, 8, 1, 3, and 6. Okay? So there are two methods to calculate Spearman's correlation depending on whether, number 1, your data does not have tied ranks, or number 2, your data has tied ranks. The formula for when there are no tied rank is P is equal to 1 minus 6 summation of D squared all over N times the quantity of N squared minus 1, where Di is equal to difference in paired ranks and N is equal to number of cases. The formula to use when there are tied ranks is P is equal to summation of paired score times X paired score minus X times the quantity of Y minus Y all over square root of summation of paired score times the quantity of X minus X squared times the summation of paired score times Y I minus Y squared. Okay? So, we can describe the strength of the correlation using the following guide for the value of RS. So, the strength of a correlation. So, value of coefficient RS can be positive or negative. So, 0.00 to 0.19 is a very weak correlation. But, if it is positive, so a very weak positive correlation, okay? But, if the given RS or the given value of coefficient RS is negative 0.10 perhaps, so the meaning of it is a very weak negative correlation. Okay? So next, we will we have the example number 1. So to calculate a Spearman rank order correlation on data without any ties, we will use the following data. So English and math scores. So English scores is 56, 75, 45, 71, 62, 64, 58, 80, 76, 61. And the math scores is 66, 70, 40, 60, 65, 56, 59, 77, 67, and 63. So, we will get the hypothesis of this data. So, HO is there is no monotonic association between maths and English marks. And H1 is there is an monotonic association between maths and English marks. So we then complete the following tables. So as you can see, there are the English scores and the math scores, and also the ranking of English scores and the ranking of math scores, in which we will get their difference or D. So like for example, 9 minus 4 is equal to 5, right? 3 minus 2 is equal to 1. 10 minus 10 is equal to 0. So 4 minus 7 is equal to 3. 7 minus 4 there is equal to 3. So ato ang D din is siya absolute value, which means it can only be positive. Okay? So our D squared is 25, 1, 0, 9, 1, 16, 0, 0, 1, 1. Okay? So we will then calculate the following, which is the summation of D squared. So the value of the summation of D squared is 54. So we will then substitute this into the main equation with the other information as follows. So P is equal to 1 minus 6 summation of D squared all over N times the quantity of N squared minus 1, right? So P is equal to 1 minus 6 times 54 all over 10 times the quantity of 10 squared minus 1. So 1 minus 324 all over 990, 1 minus 0.33, and P is equal to 0.67. Okay? So as we get the coefficient RS or coefficient P, which is 0.67, so we will then have the decision rule. So we will accept HO if C is lesser than 0, if C is lesser than or equal to 0, and we will accept the alternative hypothesis if C is greater than 0, right? And we have the coefficient of 0.67, which means that we will accept the alternative hypothesis. So we can conclude, hence, we have a P or RS of 0.67. This indicates a moderate positive relationship between the ranks individuals obtained in the maths and English exam. That is, the higher you ranked in maths, the higher you rank in English also, and vice versa. So that's all. Thank you.